All right, it's been a few days since I've provided an update, but I have been hard at work with various aspects of our game, including some engine stuff to make it easier to render more characters. As you can see on screen, we have 2 characters. We can have many more. With just a couple lines in the world file, we can define a new entity that has basically a spine rig. Spine is the software we use to create these 2D animations. And we are creating them from scratch. This is the one thing that we are not porting over from Unity. We are recreating the characters in Spine and then importing them into our game engine and then rendering them with currently DirectX. Before we were only rendering the character, and it was hard-coded to specific file paths for the player. And we needed a way to be able to express other characters in our world and essentially establish entities for like the king, the peelers, etc., and then tie them to an asset. In the last video, I covered the asset database, which we used for sprites. It has been extended to support spine assets as well, which are a little different than sprites. They're actually meshes. Behind the scenes, they act very much like meshes. So if I hit play, you'll see that the character, oops, and I need to actually be on the window. You'll see that the king falls as well. So character physics has got revamped. It has been moved to the component system. And now in the update loop, we do a batch update. Specifically in the physics update, we do a batch update over all characters. So it's very efficient, unlike Unity where we're kind of just slapping physics components on game objects and then calling it an update, and that can run in any order imaginable, unless Unity's doing something behind the scenes to try to batch it. But there's a reason why Unity's trying to introduce ECS with the burst and the burst compiler and the other optimizations, because you can pack everything into a tight array and just iterate over it much faster than just sporadically throwing components into a Unity scene. But we have the freedom to kind of organize our data however we want, so character physics are being iterated over in batch. And I can kind of show that later in the video. But yeah, let's take a dive into the spine rendering stuff because it's very, very cool. And basically, let's see how we can set up more characters. So if we go to the world file, which we have over here, let me close some of this stuff. So in our world file, you can see we defined a couple entities at the bottom here. The first one is our player. So also before this, we were hard coding the player, so he wasn't using the entity system and he wasn't using any components. And now we have this new concept of a update behavior, which is a very generic way of calling a function. In the future, we might have components that are more specific. Like, for example, the character physics, it has its own batch update, so we don't provide a update behavior to move the physics. The physics moves on its own in the update loop, right? Whereas this right here, this update behavior is very specific to the player. This is like the player input and the player animations and all of the player specific logic. And it's generic because it doesn't have any data tied directly to player, right? Or to this update behavior. It's just a function pointer that calls a update function. And then down here we have components like player, which have no data currently. And the reason there's no data is because it's all been set to default values in the code. In the future, we may expose these here so the designer can tweak them. Instead of having to go into the C++ project and change the defaults there, we can actually change it on the entity. And in a previous video, when I talked about the entity system, I mentioned entity references, which are like prefabs. So this may end up becoming a player prefab that we can reference in multiple scenes, and that's very nice because if we do change values on the player, they'll be consistent across all levels. Right now, it's just in the world file, so this is an instance that will be very different than another player in a different file, so definitely need to get that entity reference system up and running. And then here's another new component, which is called Spine Renderer, and you can see it's tied to asset ID number 2. And Spine Renderer is basically the component that we iterate over in the render loop. and to render all the different skeletons and their poses. And the spine renderer, even though it looks 2D, it's very much a 3D mesh. That's how they do the bending and the manipulation. And it does have a skeleton, which plays animations. It's very much like what Unity provides, but it has a lot of nice features to it, especially with skins, where you can turn on and off different skins for the same character, so you can change like what they're wearing and what they look like. And I think you can even control like what kind of constraints or IKs they're using, which is very, very powerful, just based on a skin identifier. And then, of course, we have the character physics, which I mentioned. You can actually set the size. This is no different than the size we've already had, so this was just copied over from the hard-coded values. But what's really cool is like we can define, this is the king. There's no identifier, so it's hard to tell, but trust me, this is the king. He also has a spine renderer, and he references asset ID 4. And you can see here he has a character physics, which is the center point of the collider is 0, 3, and then the size of it is 2 and 6. This is the half width and half height. We store the half height and half width, and then in the game, if we need to get the full size, we just multiply by 2. But most of the code operates on half widths and half heights, so no need to make it the full number here and then divide in the code. We just use the half width and half height, and then if we need the size, which is rare, we times it by 2. I think in Unity they call this the extents of the bounds. So yeah, this is how we defined the king. And let's take a look at the asset IDs, because this is also different. So let me open up another window here, and we'll go to the asset index. So for those who don't know, I did mention this in the last video, I think, but this is basically like the project browser. So this asset index is no different than the projects folder in Unity. It basically is a list of all the assets you have. I think Unity uses metafiles for this and does some kind of search over the metafiles to generate this database themselves. We kind of just stick everything in a single file because, well, we can. And this defines all the assets in our project currently, excluding tiles, because tiles are doing their own thing, but they should be a part of this. There's a little bit of a refactor that needs to happen there. And what's really nice about the asset system is it allows us to define properties for each type of asset. So for example, the sprites have pixel per unit and pivot. Pivot is actually new. We'll take a look at that later in the video. But we also have the spine asset, which has different properties. So you can see here it has an atlas path, it has scale, and it has a default mix, which we use for blending the animations. So this is like the time, I think, or normalized time for blending. So if you blend from idle to walk, the default mix is going to be 0.2 normalized time. So if it takes like, I don't know, X amount of frames, then you take 0.2% of that time it takes to run those frames, and that's how long it takes to blend. I may be wrong because I might be thinking in terms of Unity, but the docs are pretty clear on how this works. And you can override it, right? You can set different mixes for different transitions. So you can say, oh, yeah, we want to use the default mix for these animations, but when you go from, walk to swing your sword, we want it to be very quick, so we can set it to 0.05 instead of 0.2. Scale, we have various scale factors. We're still figuring out how this works. It seems like it's inconsistent, so some of these use 0.002, some of them use 0.004. Preferably the scale is 1, and it is relative to the player size or some unit square that we're using. But we're still figuring that out, so I exposed it here so we can tweak it per character. But hopefully in the next couple weeks we can come up with a standard so we don't have to tweak this too much. But yeah, it does have the same data as the other stuff. So like every asset has an ID, a type, and a file path. And that's the same for spine. And so when I said that the king is using asset ID 4, you can see here that the file path points to spines, flayed king, and then there's a skeleton JSON file, and there's also an atlas which tells us how to load the textures. So yeah, if I wanted to load, like for example, let's take a look. Let's load the flayed nun. You can see she's been defined here under ID 5. So if I wanted to create another character, I could copy the king. And right here, like when I did this, this is synonymous with creating a new game object in your Unity scene. Here we're creating a new entity in our world. And then I can change the ID to 5. I'm not going to tweak the physics or the size of the physics. We'll just keep it as is. And then let's set this to, let's see, the player is at position 11. So let's just set this to like 5. Maybe that will work. And we'll keep her at the same height as the king so she can fall, because she also has character physics. So just like that, I've added a new entity to the game, which this was harder to do before because it was all hard-coded. So now you can see Night Collider is actually pretty good for her. Now you can see she's in the world, she has a collision, and it loaded. And if I hit play, you'll see she plays her first animation. So right now it's all coded to play the first animation in the list. I don't have a system for setting those in the files. I do have the ability to control them in the game engine or in the game code, but not externally. So it'll just play the default, which is currently the first in the list. And yeah, it's so easy. I can make multiple copies of her. Again, this is where the reference system comes in handy. But I could create another none and say, okay, let's put this one at like 8. Hopefully that's enough space. Maybe we'll do 9. And just like that, I've added, two Razor nuns to the game. So that's very, very powerful. And those are our 2 bosses for this level. And we did add all the other characters. So Harlan's been hard at work converting over all of our characters. He still has some more to go, but we got the imposters in here and all of that. So obviously, like, this is what we're doing now to add new assets and new entities. But in the future, what we're going to do is when you hit play in our editor, like basically you'll have our editor, which will be a bigger window. It'll take up the full width. You can resize it. You'll have gizmos like this. You'll be able to click on the entities, move them around, and you'll be able to modify the data that's associated with each component. And again, I want to make it clear these components are not mono behaviors like Unity. They don't have behavior, they have just data. It's up to the programmer to add that behavior. And we're not going to do any type of scripting language because we're a small team and all the programming is going to happen in C++, which is, that sounds more complicated, but it's actually simpler because you don't have to juggle something like Lua or C# or some other scripting language with C++ and make that interface. And then let's say the scripting language is doing something that's inefficient. We need to move that to the C++ code. We're not going to do any of that. We're going to do all the code in C++ and then expose the data in the editor so you can tweak it. And then that's how we're basically going to do everything. Because like right here, when you see the player moving around, that's C++ code. It will stay C++ code, and it just modifies accesses the data that we provide through the components. Sweet. So you can also see I have this spinning sword over here, and if I pause the game, you can see it has collision to it. And I think in the last video we talked about pixel per unit, so this is like scaled properly to the size we want based on the pixels and what pixel per unit value we set. The one thing we didn't have though was pivot, so you'll see it's actually spinning around the center point, which was something that you couldn't do before. In the old system, the pivot point was always 0, 0, which is actually this corner here. And it's rotated, but basically 0, 0 is always the bottom left corner, and it's the same with the world. The world's pivot, or the world's origin, is 0, 0. It's the bottom left. So that's just a rule we follow in here. So you need to be able to set the pivot per object so you can do stuff like this where you rotate around the center. So if we take a look at the file here, it's going to actually be the same file as we did for spine, but you can actually set the pivot value for objects here. So for example, you can see the basic door is set to 0, 0. And when I hit play, you'll see that this is going to be somewhere around here. So the sprite is actually supposed to be rendered inside the box, but the pivot point is at 0, 0, which is where the texture starts. And if we look at this sprite in the file, let me go to sprites. If we take a look at this sprite, you'll see there's actually padding here where that makes sense. So this is 0, 0, and that lines up with what we see right here, right? So if I wanted to, I could go in here and I could say, okay, we need to fix the pivot. and we need to set it to 0.5 on the x-axis. So basically this would become 0.5, and then I can run this, and now the doors are centered in their collision, which is very nice, and you'll see that fixes it for all the doors. And the reason it fixes it for all the doors is because we modified the asset, not the instance in the world, right? And if we take a look at the sprites in the scene here, you'll see that all the teleporters have a sprite component that uses asset 0, which is the one we modified. So assets are very similar to prefabs. In fact, a prefab, or in my case, an entity reference, is an asset. We just haven't incorporated it into the asset system yet. And when I change the values here, they reflect across all entities that use that sprite. So that's very nice. That's very powerful. But this also means that we can rotate it around that point. So as you saw in the game, we were rotating around 0.5 and 0.58. I can change this to something like 825. And then when I run this, it will rotate around the hilt of the sword. And one thing I haven't fixed yet is the collision doesn't respect the pivot, so that's something we're going to be working on. But if I rotate this or turn this on, you'll see that it's now rotating around this hilt point. And I had to do some rendering math to make sure that works. Behind the scenes, this is DirectX. It is 3D, and we are using matrices to basically scale, rotate, and translate these. And in order to rotate around a pivot, you have to do some weird translations and scales in the right order to make sure that it looks correct. So this was a little wonky. Like I said, I still need to fix the position of the collision, but the collision does rotate. You can see that blue box is following it. Okay, so let me go back to our file, and let me change that back to 0.5. And then let me go to where the ethereal sword is, and we'll talk a bit about that. So very similar to the player, it also has an update behavior called ethereal sword. I'm not sure if I'm going to keep this, but there is a function tied to this identifier that we use to rotate the sword. It has a sprite, it has a sensor, and the reason it has a sensor is because it has a damage component. And right now, this is a very simple component. In the future, we might do something like this, where like you could do like, oh, it has frost damage, etc. I just put frost. That's random. That's not anything related to the ethereal sword. But basically, we can tag the damage, and we can use that. And we can have multiple tags as well, but we can use that to determine like if a character takes more or less damage, which is actually something we were already doing in Cultist Astronaut. Some enemies are more immune to certain damage types and less immune to others, so there's certain weapons you can use to kill a boss faster. And so this ethereal sword, if you touch its sensor or its collider, it will damage you. So let's take a look at that. And I want to move this over, or at least let's actually get rid of the king temporarily, just so I can run over there, because his collider still acts like a solid. You can't run through characters yet, so that's problematic. So my collider is right here. It looks like I need to make it a little taller to encapsulate the head, but that is our collider. So if I jump into this and get hit 4 times, I got hit 4 times because it's rotating, I will die. So the player does have health, and he does take damage when he enters the collision, and he'll die. We currently don't have respawning implemented. We're going to be working on that soon, and that's also going to reset the room, very similar to what we were doing in Unity, where all the enemies reset and you spawn back at the checkpoint. But yeah, we'll get to that. So right now you have to like close the game. Like you only get 1 life in this version of Cultist. And just to show that a little better, because I did die after 2 hits, I was standing in the center, so I was getting hit twice. So if I 1, 2, 3, 4, right? So that is working correctly. All right, so yeah, we did the damage component and the player death, and we talked about the pivots, talked about spine and the physics refactor. I think that covers everything that has been worked on. There is some stuff we need to do next. So the big thing is projectiles and aiming. So we do have animations where the player can aim, and we want to be able to control that via IK. In Unity, we were doing some weird directional aiming vector, and then we translated that to like a blending tree in Unity, and Harlan had to be very specific with the animations to make sure that it lined up. With here, we can just use an IK and set it to where the mouse cursor is pointing. And same for the enemies, we can have their IKs point towards their target, which is most likely going to be the player. So we're going to add projectiles and aiming, and then, like I mentioned, we need to expand the damage system so we can determine if, like friendly fire, for example, is a problem that we'll have if an enemy shoots a bullet and it hits another enemy, right? We want those bullets to go through those enemies and hit the player. Maybe they don't go through the enemy, but I think in our current implementation they do in Unity. So we want to get that up and running. And then, of course, the big thing, which is a basic AI. So a basic melee unit, the peeler, for example, where he just runs up and he smacks you with his weapon. And then from there we can start expanding and copying. I shouldn't say copy because we have to basically translate it, but we need to take our AI in Unity and translate it over to this new system. So yeah, that's my update for the last couple days. Thank you.